Welcome to my channel. In this video we will try to repair this board. Its model is Texo Optimo. It's from a company called Sonfi. It's a French company who made door opener. This board is for a overhead door. We have here those two leads for it's an LED and a receiver for the encoder. In order to know the position of the opener, you can see here the system is an optical encoder. We have here the transmitter LED and the receiver. When the wheel turns, it cuts the beam, and we got a square wave to the microcontroller. We have here the bulbs. It's a 12 volt. You can see here 24 volt and 21 watt. They use the PCB as a contact for the bulb. We have here the antenna, the start button, the flash. This is the 24 volt for accessory, and we have the stop and the security. They are bridged here. I tested the board in place, and we have now signal of live. The remote work properly. I will first remove the sensor for the encoder, the LED and the photodiode or the receiver. We have in some plastic retainer. Here we have the little board here. Now we will unscrew those toe screw. And we will, this is maybe for the ground. It is connected to the earth maybe, or to the chassis. We will remove this one, and we must remove the bulbs here. It has 4 buttons here for programming. This one for the remote control, and this one for programming the opening and the closing of the Now we got the board. Here we have the 4 buttons, the microcontroller. Here we have the receiver. This is for the receiver. Here we have the switching power supply. And here we have the tow relays to control the motor. It's a DC motor, 24 volt DC motor. With those MOSFET maybe. We have 2 power supply here. We have a standby one, and we have a 24 power supply, the second one. Here we have the socket for the bulb. this MOSFET might be, it switch the light on and off. And here we have the 4 LED. We will first test the fuse. The fuse is okay. Now we have maybe a bridge rectifier here. We have 4 diodes. We will see if we have this filter with this capacitor. We have here a 4.7 ohm, 5 watt. We can test this first. It's okay. Now I will switch to the diode mode and I will see if we have here those for the primary rectification, 400 volt, 22 microfarad. So I will put here the red leads here. I will see with the positive. This one is the side the positive, so I will put here. We have 1.1 because we have two diodes in series, and here we have 1.1. So I will do the same thing with the negative side. 0.5 and here 0.5. We will see. We will power the PCB and we'll see if we have a 320 voltage here. I will connect the power. I will connect those two leads here, live and neutral. And we will see if we have. I will power the board and we will see if we get the standby voltage or not. Here some buzzing here. It draw about 3.6 watt. I will measure the output voltage. The main one in the main capacitor here. We have 325 volt. I will search for the secondary rectifying cap. Of course the voltage will drop here. Generally they put a parallel capacitor with the resistor with those capacitor. We have 223. It's dropping now. This is the high side, the hot side, and this is the cold side. So the secondary may be here. We have a filter. We have one switching power supply, not a two. This is the filter, not the transformer. So we have this principal power supply, we will see if we have a voltage in these capacitors. This is for the secondary. So we will see here we must have 24 volt. Now we have 0.5. I will put the power and I will see here we have 28 volt. So the power supply is okay. We have 28 volt. We found a 28 volt here for the motor, and now we must find a low voltage for this microcontroller. We have here a secondary capacitor, and we will try to see if there is a voltage there. Now I will try to measure the voltage in the secondary capacitor. Here we have 28 volt here, 28 volt, and the secondary capacitor is here. $27 volt. 27 volt. We will see this capacitor is rated for 15 volt. $100 microfarad, but it's near the microcontroller. It must be, I didn't find a DC to DC converter here or another. This is the 2 op amp. We have a small SOT23 component here. This isn't any optocoupler here between the two sides. Yes, we have only 2 pins here for the primary. I wonder how the feedback is done between the primary and the secondary. This one we have here. I will test on those small capacitor. So we have the ground here. I must find the ground. Maybe one of the leads is for the ground. It must be this ground. This is the ground, but it's not connected to any leads here. It's not connected. I will see if they hold the same. Here we have the ground for the top capacitor and this. So we haven't the same rectifier diode here. They are not in parallel, those capacitors. So we have 2 secondary. I will measure here in this. So I will solder a ground wire, maybe in this side. I will solder a ground wire to test. We have here a black wire. So I soldered the ground wire here. I will connect this ground wire to the multimeter. And I will test our voltages here. I will put the power on. We found 4 watt. It consumes 4 watt now. I will test here. 28 volt. And for this capacitor, 5 volt. So we have 5.6. We have a regulator here. And this one, here 3.3 volt. So we have 2 regulators here. We have here 5 volt, 5.5 volt. This diode is for 28 volt. 28 volt. We will test now if we have here. This button is to program the remote control. I will, so it's the one in the right prog. I will put here the bulb and I will try to program the remote. Nothing. We get nothing. I will test the bulb. See, it's okay. 2.2 ohm. It's okay. When we press this button, the LED must flash. Maybe software problem. All the voltages are okay. I must find. So here we have here 5.5 volt and 3.3 volt. I hear a buzzing here from the power supply. I will see if we have, I will test here. We have 25 volt. Here we have 0 volt, and here we have 0 volt. I will try to push the button. So here we have, I will test this MOSFET. I bring this little scope in order to get information about the power supply. I will power the scope now. So we have here 5 volt and we have here 3.3 volt. I will select 2 volt per division, and I will power the board. Now I will see here the 3.3 volt. We have here 3.3 volt. We can use 1 volt here, and we can see here we have 3.3 volt. Now I will test the 5 volt rail. We have some noise here. We have noise on the 5.5 volt. It's not a clean power supply. This circuit is a linear low drop voltage, so the noise may be coming from the primary. We have this circuit here is a LM2936 circuit. It has input and output. It has a fixed voltage. Here we have 3.3 or 3 or 5 volt. The other tiny one, maybe it was clear here, is for the 3.3 volt. So I will test for the primary here, for the secondary here, 28 or 27 volt that power this circuit. I will choose here maybe 10 volt per division, and I will see here we can find about 30 or 28 volt. We have a little noise here, but we can see, we can switch to the, when we test the 5 volt one, we can here select the 5 volt to see the amplitude of the noise. We can see here with 1 volt, with 2 volt per division. we have here about 2 or 3 volt of noise. I will switch to the IC. We have here we have the IC, and I will see we have a bad contact here. This scope, maybe it's near the voltage power supply. I will test here. It's okay now. I will see here for the 5 volt rail we have here the noise. We can select 1 volt per division, and we will see it about 2 volt here of noise. I will use 20 milliseconds. I will now test for the 30 volt if I have the same noise, so it comes from the secondary. We have a little noise. We have only noise in the output. I can test also here for the other secondary. We have no noise here. Here we have a little bit of noise, and in the 5 volt output we have the noise. But in the 3.3 volt we have a clean voltage here. Maybe the problem is from this capacitor or from this one. I will try to put a capacitor, this one, in the 5 volt rail, and I will see if we still get those noise. I will connect the minus to the ground. I will put here the scope leads, ground of the scope. I will warp a red wire here to the positive. Now I will try to, here we have 2 volt division. I will power the board. I will test primary here without the capacitor. We have the noise. I will here try to put the capacitor in the 5 volt. Here we have this circuit is powered by 5 volt. I will put here the probe, and I will apply here. I will put the capacitor. We have a clean, and now it is working. So we found the fault. The fault was this tiny capacitor. I will now power off the board. I will replace this capacitor. We have the solder on iron is working. I will see. It has a 47 microfarad, 6.3 volt. This one is 1000. I will search for an appropriate one. It's linear regulator, but it needs secondary capacitor, smoothing capacitor. I will search for a new one first. Now I will remove the faulty capacitor. I will apply some fresh solder here. This is the faulty one. It's 47 microfarad, 6.3 volt. I will get the one from this board. It's from 3 LCD projector. Here we have the 3 connector for the 3 LCD. We have here 46 microfarad, 6 volt. We will remove this one. So this is the newer, this is the outlet capacitor. They have the same footprint, almost, they are almost the same. I will here use capacitance. They're marking the negative side, so I will use, this is the newer one. It has 50 microfarad. The outlet one, it has 47 microfarad. So maybe it has a bad ESR. Now I will try to solder this capacitor. I will apply some fresh solder here. And here. The same thing here. We'll put the capacitor in the right place, and I will apply some heat on the 2 leads here. Now it is secured. I will verify if there is some short or not. I will try to power the board and we will do a test. I will remove this ground. We will power the board now. I will try to press the button. Oh, it's okay. It's working now. We have a response. The relay is closed. So the board is okay now. After replacing the capacitor, the board now is working. We have the bulb flashing, we have the red light. When we push the button, the relay closes. And we have here the read LED for the encoder. So we have here the secondary of the switching power supply. We have the rectifier diode, we have the main capacitor, this one. We have here 28 volt. To get the 5 volt, I use a low drop regulator. It's LM 2936. We have here the capacitor that we replaced, and after we get here 5 volt rail, and we have another regulator to output a 3.3 volt for the microcontroller. So the problem is with this one. When measured with the scope, we found some noise here in the 5 volt rail. Although with the multimeter we found here that it has a 47 microfarad, but maybe it has a bad ESR, which caused the problem. Now we get to the end of this video. Thanks for watching and have a good time.